quiz number 1, as we go through this stuff, if you didn't get it the first time, as we start to go through the lecture, you should be able to get it. So these are some of the fundamental concepts that start to build up on top of each other. So with that being said, let's go over the quiz questions. Number 1. Let's record What molecule provides the activation energy in glycolysis? You guys remember what the molecule is? This is, I'll give you a clue. This is an answer from quiz number 1. ATP. What molecule provides the activation energy? And so when we talked about the kinetic energy is required, or the energy that's required for activation energy, okay? In many examples I've used about heat starting to light up that match. And in that form of energy, we were looking specifically as the energy currency as it relates to human physiology, and that's ATP. And if you remember in glycolysis, we looked at that energy curve. We needed to invest 2 ATP in order to drive that reaction forward to generate 4 ATP. So our net ATP gain from glycolysis was 2. Okay?
If you get one answer right, is that half point?
If you get one, that's fine. You'll get half credit.
Okay.
So some of these questions are geared so that there might be 2 answers required. You'll get half credit for it.
But the answer for both, I just say 2 ATP. Is that okay?
Yeah, as long as I see 2 and then ATP.
Okay.
No matter if there's 2 comma ATP, 2 divided by ATP. Okay, as long as those are there. I get it. Okay. Well, ADP isn't, it's the product of that. But what we're doing is the ATP is the one that contains the most energy for it. So ADP, I'll think about it. Energy released in a reaction is referred to an blank reaction. Exergonic. Okay. So the correct term is exergonic, because exergonic relates to energy exiting the system. Now, for those of you that put catabolic, I'll give it to you. All right? And the reason being is that catabolic refers to the breakdown. It's purely referring to your reactants and then your products. You're breaking apart a big molecule into a smaller molecule. So catabolic refers to just what you're working with, but the actual energy is exergonic. Okay? What is the primary mechanism that ATP synthase relies on to generate ATP from ADP and phosphate ion? And so the mechanism in this place, what drives ATP synthase to continually churn? We talked about it and you even saw it in the video. Something has to drive. And that drive, that term that was on the top of that slide was chemiosmotic mechanism. If you refer to anything where you had hydrogen moving down, that's okay. You don't have to have chemiosmotic. You just had to talk about hydrogen moving down from a high gradient in the intermembrane space of the mitochondria, moving down into the matrix of the mitochondria. So remember, we were talking about this waterfall, right? We had NADH and we had FADH2 that was coming in and contributing those high energy electrons through all those enzymes on the cristae of the matrix. And so that drove, when you had electrons that passed through, you had hydrogens that were passing through from a low gradient to a high gradient. You were literally just shoving all these hydrogens into that intermembrane space. And that last enzyme was ATP synthase. And that's where you had that cascade, you had that waterfall flowing through, and that would drive the phosphorylation of ADP. Yes?
What if I put like oxidative phosphorylation, and then in parentheses I put composed of electron transport chain and chemiosis? Like the last step, that's where
I'll look at it. I'll look at it. If the general rule is if you give me the answer, I'll give you full credit. If you're getting there, I'll give you half credit. If you don't, if you're kind of far from the if you're far from the answer, don't.
It is oxidative phosphorylation.
It is that is true. That the whole process is oxidative phosphorylation. It was oxidative phosphorylation refers to the oxidation of NADH and FADH2, and that's what's contributing to that. Okay, but the actual drive for all of ATP synthase is the chemiosmotic mechanism. Chemi referring to hydrogen ions, and osmosis is the osmotic mechanism, the moving down from high gradient to low gradient. I'll take a look at your answer. I can't really go through them right now, but at least thanks for letting me be aware of that. Junction that creates an impermeable barrier between the lateral sides of adjacent epithelial cells. Now, that's a kind of a mouthful, but you're looking at epithelial cells, right? And in between, I'm talking about these junctions in between that really hold them together. What were those junctions called? Tight junctions. Okay. So think of people, oh, really good analogy I just thought of, Red Rover, people holding on. You don't want things to pass through those tight junctions. The only way to get through is for that person to literally just move through you, which is kind of weird. But anyway, the idea is it has whatever needs to move from the lumen to the other side, it needs to pass through the cell itself. Term used to describe which side of the epithelial cell that is exposed to a lumen or opening. Okay, and the term for that, we saw two sides of it. We saw the basal side, which was the anchoring, where we saw the anchoring junctions that would hold it to the connective tissue. The other side was apical side. So think of the apex of something. It's the top of something. And that's where we're going to be able to see the cilia. Now, if you remember the ependymal cells that I talked about that produce cerebrospinal fluid, we saw that the top of those cells had these cilia that move cerebrospinal fluid. Okay? So those are typically what you would see in an epithelial cell, that the characteristics of them would be expressed on the apical side. Describe any integrative function of the nervous system. And if you remember, we had sensory, we had integrative, and we had motor. What was the integrative functions?
Perception.
Perception. Thinking, decision-making, memory. What's that? Processing of information?
Processing and combining.
Yeah.
Control center /
Okay, yeah. If you have perception on it, you're good.
Yeah.
All right. Which of the neuroglia in the CNS are responsible for maintaining the blood-brain barrier? Astrocytes. So these were the projections of wrapped around the capillary, and it served as an extra gate for things to flow through. So in order for stuff in the blood to flow into the brain, it had to cross through the astrocyte cell membrane.
But on the PowerPoint, I was reading it. It said something about blood-brain barrier for the tight junction.
So that's one way of contributing to the blood-brain barrier, is that the capillaries have the tight junctions around them, right? But if we were looking specifically from the neuroglia that's involved, that's the astrocyte. Electrical voltage difference measured across the cell membrane is called?
Polarity.
You're getting there. Membrane potential.
Oh, if I put polarity, is it half point? Okay.
What about electrical gradient? Electrical gradient?
Electrical, well, the electrical's in the question.
Yeah.
Gradient, yeah, I'll look at them and I'll give you half credit if you kind of got the term.
There's electrical and chemical, right? So that's why I put electrical gradient, because it had electrical on it.
We'll see.
Can we just
We'll see.
retake this
We'll see.
quiz?
You can retake it next semester. List two factors contributing to the negative electrical voltage difference. So list two factors contributing to the negative membrane potential. And I gave you three big ones. All you had to do was give me two. You guys remember that? Number one, what was the primary one?
Potassium.
Moving out.
Moving out.
Potassium, right?
Yes.
Leaky potassium channels, pushing potassium out.
Out.
You push a cation ion that's inside the cell, move it out of the cell. It's going to make it more negative on the inside. Mechanism number two, what was the second thing that made it more negative on the inside?
The closing of the channel.
Was it sodium what?
Moving in.
Sodium's on the outside of the cell. I don't, what does
Moving
sodium
in.
to do with it? But you're on it. Sodium, potassium, huh? Right? 3 ions out, 2 ions in. Okay, and then there was one other one. Yes.
So I kind of literally sodium.
Oh, hello. Are you asking if you could get credit for something? Okay, well, let's answer the question first. How about that? What's the other one?
Anion. Anion.
What anions?
Anions stay inside.
Which anions?
The big molecule.
Big molecules, okay. Amino acids. Any of the acids on the inside? We had phosphate ions on the
Phosphates.
inside. We had organelles. We had proteins.
Protein.
Those things stay on the inside, and they're fairly negative. Okay, so that was, if you look at the slides, you'll see it on there. Yes?
We can just refer to them as anions, or?
Okay, I'll give it to you. If you say anions, that's fine.
Yeah.
What did you say ions? Like
What ions?
increase in ions on the inside, decrease.
Which are they positive ions? Are they cations or anions?
Anion.
Yes, I forget.
So what if, like, for one of your options, you're like potassium going out, and for the second option, you're sodium gated ion channels?
What was that? What was the second one?
Sodium gated ion channels, which channels would cause the sodium to go in and out of the cell?
Sodium going into the cell would not make it negative on the inside. You're looking at a cation going inside. You might be leading into what today's lecture is about, but this is specifically about the resting membrane potential. What keeps it at rest? And at rest, I mentioned that it was just leaky potassium channels. Yes?
Ligand gated channels?
Ligand-gated channels. And that's tied into today's lecture. And then what ion is, oh no, I'm sorry, I'm on the wrong one. This term refers to an increase in the electrical voltage difference. So there was a difference from the outside of the cell, which was 0 millivolts. The inside we measured had a negative 70 millivolts. So I'm talking about an increase in that. I even give it to you, it says below negative 70 millivolts. What did we call that? And this was an increase tied into the polarity beyond rest.
Can I say hyper?
So it's not depolarization.
Hyperpolarized.
Hyperpolarization. That's below resting. Okay?
I put hype.
You put what'd you put?
Nothing. It has no relevance to it. Just
You put hypopolarization there. You're not.
I just put hype.
Hyperpolarized.
Put hyper. And what ion would cause it to make
Potassium.
more negative on the inside?
Potassium.
Potassium. Potassium leaving the cell, right?
Yes.
And exactly what we'll be seeing today. So hopefully you got that concept because we're going to be going over that. And we'll be going a little bit quickly because we're building on top of it. So hence why I kind of purposely put this quiz, because if you didn't really get the concept of what we talked about on Tuesday, you're going to be really lost today. All right. The ability of, and then this is the last one, the ability of a cell membrane to move ions and other substances in and out of the cell is called, specifically talking about the ability of a cell membrane to move ions.
Permeability.
Permeability. I gave you half the answer was ability, and then permeability is it. And then we'll be able to see, we'll even explore the concept of permeability a little bit more. What's that?
Semi-permeable membrane. I'll take half.
I'll take it.
I'll take
I'll take it.
A quarter?
All right, so